Hey everybody, this is Larry. This is day 2 of the June Leetcode daily challenge. Hope everyone's staying safe. Hope everyone's staying healthy, and you know, make sure you find a place to love someone in your life. Let's get to problem 2. Delete node in a linked list. Write a function to delete a node except the tail in a singly linked list. Given only access to that node. Given linked list, blah blah blah, which looks like this. We will move 5 and then okay, go. Okay. So there might be a double there. Do not return anything. The given tail will not be the tail. Okay. I think the thing that I would think about in this case is what happens when you remove the head. I think for every other case it is probably mostly okay, in that you just have to do some checking. The linked list will already have 2 elements, but it doesn't seem like it does say anything about the head. So yeah, and we could kind of test that, right? Only because we're cheating, half and quote unquote, but we're just here to learn, so it's okay. But let's just see what the expected answer is, or whether that's even valid input when we remove the head. And we remove the head, what should we return, right? So that is the expected answer, and that's okay. Oh, I forgot to change to the second one. Or at least that's the expected answer. We just have to be really careful about what that means, right? Because in that case, this is a really weird problem setting, because in that case, we want to, yeah, our head would still be, our head node is still the head node, because we're giving the head. Let's call this head just to kind of make it clear. But here we want to change the value. So I think there are only 2 cases in that case. That is, wait. Am I missing the input? Let me reset this. I think I'm missing some understanding. That, where's the head input? Am I missing something? I'm just trying to right now. Well, the first thing I would say is that this is a very weird, poor question, in the sense that I don't know what. So node is the node that we want to remove, but we're not giving the head, right? Okay, I see what it's saying, kind of. So this is a kind of, it will take a little bit time to understand. Usually they're a little bit clearer, but maybe it is actually sufficiently clear. It's just that it takes my head to wrap around what the problem is actually asking, considering that it feels a little underspecific, but it's actually enough to do what you need. But it's just that it's a little bit weird. But there might be a way. It really depends on how you want to call delete, because ideally for linked lists, and linked list nowadays has become more of a trivia thing, but because I don't know, it just doesn't come up that much in real life. But what we want, if let's say we're giving a deck, then we could want the node dot, we would do something like node dot previous dot next is equal to node dot next, something roughly like that, so that the previous is next skips this, right? So now what we want to do, and it's a little bit sketchy, is what I would like to do is do something like we don't actually change the node, we just shift everything from the right side up 1. So the way to do that in theory would be just node.value is equal to node.next.value. But we do something like while node.next is not none. And then that's pretty much it. Well, node is go to node.next maybe. And then now that node.next is none, so we actually may have to add some other additional gating. But basically what we want to do is, let's say we have this given linked list that I'll put in array form. And we're only giving the pointers here. Then what we want to do is just shift this by saying this to 1, remove the pointer, set this to 9, and at the very end, just remove the .next, right? So that's basically what the strategy that I'm going to do. I already started the road on, but there are some edge cases. So next is equal next.next, kind of. This is mostly maybe right, but this is the thing where we now remove the last element, right? But let's, for some visualization, that's one just to kind of see, and that's just change. Oh, that's true. It tells you that it won't be removing the last element. I just remember that. But here we don't. What we have to do is we have to set the node that is before the last node to none, right? So we have to do something like if node.next is none, and this is before we set it. If node.next is none, then we want to set. Okay, so in this case, node.next is not going to be none. What we want is if node.next.next is none, then node.next is equal to none. Something like that. And then that should be good, except for that this would give you an error. So let's just do else. Yeah, so that looks pretty good. I think that's really most of the cases, right? What else are there? Maybe you can't do the only other case would be the tail, but which it tells you that it won't. So let's give it a go. Let's try the 2-element case first, actually. Still should be okay, but it is an edge case. Okay, so that looks good, so let's submit. Okay, so that's pretty much it. You can write this in a couple of different ways, obviously, but but the idea is still just making sure you have your edge cases. I don't think you can do better than this. And what is the complexity? The complexity is just, it's a little bit nuanced. You have to define your variables more, because L is, so maybe it's just O of L, where L is the number of nodes in the entire linked list, maybe, or linked list that are suffix of the node that you pass in, because we're given no context of the linked list. But in the worst case, it'll be O of N, where N is the number of nodes in the list. If we do not use extra space other than the ones that are passed in, and so it's all one extra space depending on how you want to define it. Again, in-place stuff is a little tricky, but with linked lists, at least that's more understandable, because in general, you want to do stuff that's in place. So the way that we did this algorithm isn't really a deletion, so, and it's not really a linked list operation, because in general, delete node should be all of 1. Yeah, I think that's all I have. I could see this as an interview question, as more of a brain teaser or trivia, but probably not that much for competitive programming. But still, it's just about being careful of your edge cases is what this problem asks you to do. And I'm going to just actually double check the solution with y'all here, so then we can learn together in case that's not the case. Swap with next node, okay. Now, why was it? So you can do this O of 1 by pointing. Usual delete of node is to modify the next one. Yeah, that's what I was thinking. So since we don't do that, okay. I guess I accept that. That is cute. I would not have gotten this one clearly. This is the O of 1 solution. But basically what it's saying is that instead of, so basically my strategy was just, something like this, and then you go from, you want to remove the 5. So what it's saying is we delete the, we how do we say it? But yeah, we set basically, we shift one over, and then we delete the one, so then this gets deleted, and then this just points there. That's actually a more clever way than what I did it. And that would also be O of 1 complexity, so that's way smarter. And the reason why you can do that is because one of the constraints saying that you cannot, or you do not remove the tail, so that's okay. Because otherwise this strategy would not work. Okay. I mean, I guess it is what it is. Sorry if my video today is not as whatever, but there's a lot of things going on in the world. Hope everyone's okay, everyone stay safe. Let me know what you think. Let me know if you find the all of one solution. I think for me, maybe you could see an interview, but this is a lot of brain teaser, a lot of trivia. I'm not a fan of it, and it's just like, hey, here's this thing. Where like, as an interviewer, I probably would never give this problem just because this doesn't really test enough of what I would expect a candidate to demonstrate, except for like random, I don't know. I guess there is some problem solving in some way, in a novel way, but I don't know. Maybe I'm just not a fan of it. But yeah, but that is definitely a clever solution. So yeah, cool. That's all I have for this problem. Stay safe, stay healthy, and yeah, bye everybody.